Dr. Curtis here. Let's talk about the properties of circles. Here we have a circle. Let's assume for the sake of argument that the circle we've drawn here is perfectly round. That means every straight line we draw from the center point to the curve is the same length. This is one of the interesting features of a circle. It's so interesting, in fact, that the distance from the center point of a circle to a point on the curved line has a special name, the radius. You'll see the word radius abbreviated as R in formulae that deal with the features of circles. Now, what if I drew another line in the opposite direction from the one I've already drawn? How long is this second line? Well, since it also extends from the center point of the circle to a point on the circle, it's got to be the same length as the first line I drew. In other words, it's also a radius. Notice that I now have a straight line that extends from one side of the circle to the other, and that runs through the center point of the circle. And notice that the length of this line is equal to 2 radius lines. This is another interesting feature of the circle, known as its diameter. Similarly to the way we use R for radius, we use D for diameter. The diameter of the circle is the distance across the circle at its widest point. If you were to draw any straight line segment starting at the outer edge of the circle, through the center of the circle, across to the other side, its length would be equal to the diameter of the circle. Since the diameter is twice the length of the radius, we can say that both D equals 2 times R and R equals 1/2 of D. So now we know about some distances related to lines that run across a circle. But after all, circles are round. So we're probably still interested in knowing something about the distance around a circle. This distance is known as the circumference of the circle. The circumference also has an abbreviation, C. As it turns out, all 3 of these distances are related in a really fascinating way. Over the years, people studying the properties of circles discovered that the relation between the circumference of a circle and the diameter of a circle is constant. To put it another way, if you measure the circumference of any given circle, measure its diameter, and consider the ratio of the two, which is the circumference divided by the diameter, you'll always get the same result. As humans' measurement tools became more and more precise, people realized that this result appears to be a decimal that never repeats. At this point, it has actually been calculated into the trillions of digits, and no repeating sequence has been found. This constant number, which again is equal to the ratio of a circle's circumference to its diameter, or again, a circle's circumference divided by its diameter, is so important in geometry that we gave it a special name, pi, which can be written out like so. So if pi is equal to the circumference of a circle divided by its diameter, that means the circumference of a circle is equal to pi times its diameter. And since the diameter of a circle is equal to twice its radius, this means that the circumference of a circle is equal to pi times twice the radius. Now, let's see if we can put all this information to good use in some practice problems. After I ask a question, you can pause the video if you need some time to do some calculations. Ready? Suppose I have a circle with a radius that measures 6 feet. What is the length of its diameter? Well, since the diameter of a circle is always twice its radius, the diameter must be 2 times 6 feet, or 12 feet. Now, what's the circumference of this circle? Again, since the circumference of a circle is equal to pi times the diameter, the circumference must be 12 feet times pi. We could do the multiplication here by first rounding pi to a certain number of digits. For example, we might use 3.14 as the value for pi and multiply that by 12 feet. Sometimes people will just leave pi as it is, which we'll do here in the interest of time. Notice that we could have calculated the circumference from the radius as well. Since the circumference is equal to 2 times pi times the radius, and the radius is 6 feet, we still arrive at 12 feet times pi as the measure of the circumference. Now, suppose that we have a circle with a circumference of 12 meters. What is the diameter of the circle? Well, since the circumference of a circle is equal to pi times the diameter must be equal to the circumference divided by pi. In this case, that would mean that the diameter is equal to 12 meters divided by pi, or 12 over pi meters. What about the radius of this circle? Well, since we know that the diameter is equal to 2 times the radius of this circle must be equal to 12 over pi meters divided by 2. This is equivalent to saying that the radius is equal to 1/2 of 12 over pi meters, which can be written as 12 over pi meters times 1/2. We can cancel using the 12 and the 2, leaving us with 6 over pi meters. And again, we could round pi to a number of digits and do the division here if we wanted to. That's it for our review of some of the most interesting and important features of a circle: its radius, diameter, and circumference. Hopefully, now you have a better idea of how these features are interrelated and how you can use pi to calculate the circumference from the radius or diameter and vice versa. Thanks for joining me at the MathCraft Math Lab. I'll see you next time.